boink, 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 boink. Chess pieces. Shiro loves chess and thus asks you to code a program that outputs the value of a given chess piece. The pieces include a queen worth 9, a rook worth 5, a bishop and a knight worth 3 each, and a pawn worth 1, just like how chess is, the king being priceless. Yep. Given the name of your piece S, your program is to provide the respective value or priceless. The first line contains the number name S of the selected piece in lowercase, outputs the value of the piece as specified above. Okay, so this question is extremely easy once you mastered the coding fundamentals. So we're just going to have a string, and then we're going to take input for the string. If the string is equal to, man, I would use dot equals in Java, but I think for C++ you can just do this. So if it's queen, then let's just go ahead and output 9. If it is, what else? A rook, then let's go ahead and output 5. If it is a knight, so if it literally says knight, then we output 3. And can I duplicate this line? How do you duplicate? Oh shoot, what's going on? Okay, I don't know. So instead of knight, there's also bishop, and then paste. Okay. And then finally you have pawn. Actually, not finally. Pawn is 1. If it is king, then we output priceless. So outputs priceless. Okay. And then extra E. Bam. So that should work. Let's go ahead and run this. Now, during a real contest, I might just submit the program directly because it's so easy. There's really no need to test it because I know it's gonna work. If it doesn't, well, I'm gonna be able to fix it pretty quickly. So there you go. I got that correct. So let's move on to the second problem. This one is called Ghoul Investigators, which reminds me of Tokyo. Sorry. What is it called again? Tokyo Ghoul. And the first word is Kaneki. So yeah, it is the anime Tokyo Ghoul. Like I suspected, Kaneki is being pursued by n ghoul investigators with the ith investigator, so an array. My mind just instantly thinks of arrays. Having a maximum speed of s, I. So an array of speeds. Since he doesn't want to fight, Kaneki will simply run away if he's strictly faster than all investigators. Otherwise, he will have to fight him. Dumb. Given that Kaneki's maximum speed is k, determine whether Kaneki can run away or if he will have to fight the ghoul investigators. Okay, so there's only two options for output: run away or fight. If he is strictly faster than all investigators, then he'll run away. Otherwise, he'll fight them. So, first line is his max speed, second is number of ghoul investigators. Then the actual array of the speeds of each consecutive investigator. Output run away. If Kaneki is strictly faster, then all ghoul investigators pursuing him, then run away. Otherwise, he has to fight them because he can't outrun all of them. Okay, that makes sense to me, so let's just get started. First line contains integer k, Kaneki's maximum speed. I'm going to go ahead, have integer k, and input that in. Actually, let me do this on all one line. So kn, and then we're going to have an array. So I'll just put this over here and have const int mm, which basically means the max value, and n goes up to 100. I'll just say 103 just to be safe. Since n goes up to 100 here, then we know that the array of all the investigators, well, there's going to be a maximum of 100 of them. So we can just legit set an array here without even thinking about it, because what's the point of thinking about it? And then we just input k, which is max speed, n, which is the cool investigators, and then after that we have to go through the array for loop and just input the array at each like index. And then what we're going to do is, honestly, we don't even need to create an array, but it's fine. So now we'll go through each element in the array. Basically, for each index in the array, we check the speed of that cool investigator. If any one of those speeds is greater than Kaneki speed or equal to Kaneki speed, then we already know that he cannot outrun these guys. So basically, what I'm saying is, if the speed at this position is greater than or equal to Kaneki speed or max speed, then immediately we're going to output, yeah, he cannot run away. Like, he's not going to get away from these guys, even if it's the same speed, because they're just going to be chasing like this. I'm guessing the ghouls can like use their attacks on them, on him. So we're just going to say fights. You gotta fight him, bro. Yeah, you ain't escaping now. And then we exit the program. So return 0 basically means, since main is a function with int, return 0 basically means stop the function, stop the program. We're done. He's fighting them. Nothing else is happening. Otherwise, if that never happens, if we never find a ghoul that's just greater than or equal to his speed, his max speed, then okay, well, why don't we just run away? They can't catch up anyway. Alright, so that's going to be it. Here we'll have all this. So fight, I get fights, and fight is the correct answer for this output. And then let's do it for this one. Clearly I inputted something wrong. 10, 1, 9, run away. Right, so Kaneki's max speed is 10. The only one ghoul has a speed of 9, so Kaneki can just outrun this dude, like seriously. Okay, so now I'm going to do vim, so I'm going to type, while in normal mode, colon, I think it's called semicolon, no, it's just called colon, %y, and that yanks the lines, so as listed here, which basically means it copies it. And I'm just going to paste. And then we get all correct. Yes, all correct. Okay, so that was also pretty simple. I'm just going to go ahead and delete these. Now, next up we have tally clicker. Oh, this is Aki, Denji. Okay, this is Chainsaw Man. So, damn, why is everything anime related on DMOJ? It's kind of weird. Aki has given Denji an important non-negative integer to relate to Makima. Denji is unfortunately not smart enough to remember numbers or write them down. Damn, okay. As his friend, you have given him a 4-digit tally clicker to store the number for him to help him impress Makima. 4-digit tally clicker. So a tally clicker sort of looks like this. It's just like a device where it has 4 numbers, and so when you click it, it updates it. It just like adds 1 to the count, and it just displays that. So that's it. Denji wishes to be efficient, not lazy. Given a non-negative integer n within the boundaries, he wants to be told the least number of clicks to display that number on the tally clicker. Okay. The tally clicker consists of 2 buttons. The first one increments the value by 1, wrapping to 0000. If the tally currently displays 9999, the second button shifts all 4 digits up by 1. Should any digit be 9, the second button cannot be pressed. So, if displays at 9999, you press button 1, it updates it by 1, and then wraps back around to 0000. But if any digits at 9, you can't do the second button, which shifts all digits by 1. Okay. The first and only line contains negative integer and desired value to be displayed. Outputs 1 negative integer, the number of clicks to display n. So this is just a typical problem. Okay, okay, so we have basically this 4-digit clicker thingy, mobobber. You have 4 slots with numbers 1 to basically 9999, so 9999. And basically, you want to find out how the minimum number of clicks to display that number, where updating goes by 1. You can either update all the digits, add 1 to all of them, or you add to the units digit by 1. And then if the units digit's 9, then you wrap around just like normal addition. So how I'm going to look at this problem is we want to maximize the number of times that we use the second button, because it does shift all the numbers up by 1, which increases by 1111. And then the more times we can do that, I mean, it just increments it so fast. Like, imagine instead of incrementing by 1, you increment by 1111. And like, that's crazy. We want to do that as much as possible so that we can minimize the number of clicks that we do. Let me create a new thing. Okay. So we have int n. We're going to take the input of n, which is cn. And then we're going to see so okay. So basically, how do we do this? Well, okay. So basically, I'm going to loop I'm going to try all like values of int I equals 1, and then I goes all the way up to 9. And then we're going to have the actual total equal to I times 1000 plus I times 100 plus I times 10 plus I, which basically means, for example, if I is equal to 3 during this for loop at some point, that basically means the total is going to be equal to 3333. So we're going to do total if the total is less than, if it becomes greater than n, that means we want to stop there. We don't want to click the second button I times. We want to click it I minus 1 times, because the click before was 1111 less than the current one, and that one was lower than the total still. So that means that we know we should just go back to the original one before. So hence we're gonna add I to the answer, which basically means how many clicks. So let's have an answer here, and then also for the answer we're gonna add n minus I minus 1 times 1000 plus I minus 1 times basically the previous, 1 1 1 1 or 2 2 2 2 or 3 3 3 3 3 or 4 4 4 4 or 5 5 5 5 number. So the previous one is going to be I minus 1 times these place values. So we're gonna have this previous value. Actually, let me just kind of copy this. So I'm gonna press V so I can select this. I'm in visual mode. Delete that. Int previous was equal to this thing. So we just say okay, and then we add n minus previous, because to get from the previous value to our actual value, so maybe n is, maybe it's like 2000. Then how many clicks should we do? Well, let's do 1 of the second. So with 1 of the second, that's going to take it up to 1111. If we do another one, we get 2222, which is already bigger than 2000, so we don't want to do that. then how many of the first buttons do we click? Well, we click them this many times. Like, that's basically it. So 899. That is totally wrong. It's supposed to be this, I think. Yeah. So that means that one click. So, and then you also need clicks of first button, of second button. So that's why we do, and we add our original number minus the previous like biggest number that we could get to with only the second button. Now we have to only use our first button, so we have to add that many clicks onto our answer as well. So now we're just gonna output this, and my voice is getting a little bit dry, so yeah. Okay, so clearly we get the wrong answer. This is not right, and that's because we're actually checking when total is greater than n, but when we actually input 9999, we're never going to get a number that's greater than n. We're just going to get 9999. Is it greater than 999? No, it's not. So let's actually go to 10. Now we're going to get to a number that's actually bigger. Okay. So it still doesn't work. And this is because I'm not actually sure, but oopsie. This doesn't work. Why doesn't it work? I don't even know how this happened. Like, okay, whatever. Shoot. Okay, before anything, I'm just gonna. Oh shoot! Wait, it doesn't even stop the loop. So if my bad. So and it's plus equals I. I don't think it's actually plus equals I. Yeah, it's not. It's supposed to be plus equals I minus I, 1 minus 1. Because it's already too much if you use I clicks to the second button, right? That's what we established. So we want to use I minus 1 because that one actually was lower than our original number. If we click the second button, I minus 1 times. Now we're going to break the loop. So let's just go ahead and select these, Control V, sorry, Shift V, which basically means uppercase V. And then put that up here. Really tired. Okay. But anyways, now let's try that again. Oopsie daisy. And now we get 9. Awesome. So that works. 101. This output should be 101. Okay, it is. So there we go. It seems to work now. So if we put that in. AC, yay, it works. Okay, now we're going to move on to question 4. So hopefully you understood this one. Okay, so you want to minimize number of clicks, and you have 2 buttons. Okay, magic barrier. I'm guessing this is another anime one. I don't know. Alright. Freyrin is analyzing a magic barrier whose strength at specific points can be represented on a 2D grid. A with n rows, m columns, and unique values. So immediately I imagine a 2D grid, which is just a 2D array basically, where you have rows and columns. And immediately I just visualize 1, 2, 3, 0, 1, 2, 3. So these are the rows, and then these are the columns. So yeah, that's just a 2D array. That's immediately what I visualize. And then you get the unique values, specifically the strength of the barrier on the rth row and secret columns is ARC. Okay, so each value in the 2D array, remember, also on Loom this is kind of hard because it disappears, but for example, a value here means that the strength of the, oh my gosh, the strength of the barrier on one end, row 1 and column 2 or column 1, I forgot which one it is going to be like the one, whatever is in the box is the value for that barrier. Okay. She asks you Q questions, so she gives you a bunch of queries and you have to answer her queries, basically. Output for all the inputs in the form of K, R1, C1, R2, or C2. And your task for each of them is to determine whether K exists in the inclusive rectangle formed by A, R1, C1, and A, R2, C2, so a sub 2D grid. Past input is highly recommended. Okay. All values of the array are unique. That's something to take into consideration. So, when determining whether K exists or not, yeah, that's really important. I'm actually not exactly trying to do this problem, to be honest, but I'll figure it out, probably. So first line contains NMQ, so the number of rows, the number of columns, the number of queries that she's going to ask. The next n lines contain m integer each, which basically means it's going to be in the format of a 2D array. And then next q lines contain 5 integers each, which are all the queries that we want to answer. Okay, we're gonna get started with these problems. When I don't exactly know what I'm supposed to do, I usually just start with doing the input, just so I feel a little bit better about approaching the problem. So let's create our integers. We also want to create a 2D array, so we're going to put the max value for each. And how big can this 2D array go to? Well, n and m can be up to 1,000 something, so I'll just say 1,003. And yeah, that's basically it. So we're going to take the inputs. We're going to take n, m, q. Then for each grid in n, for the 2D grid, I'm going to input it using a nested for loop. And then we're going to input ij. So at row I, column j, we're going to input the value inside of the 2D array. And then now what? Well, we gotta input the queries. So for each, we're gonna loop from 0 to less than q. So basically, we're gonna loop q times. And then this is a really cool trick. We're also gonna create what is it called? Local variables, just like variables that you just kind of create through each iteration of the loop. When you repeat it over and over, you create new variables so that we can input new variables over and over and answer these subsequent queries. R1, so we're going to input K, R1, R C1, R2, C2. We're going to input, so K, R1, so we create the variables on each instance of the for loop like iteration, and then we also input all of them. So that would be these inputs. Okay, does K for that question exist in the given rectangle? If so, then yeah. Then if not, then no. So let's look at the sample. So this is our grid 1, 7, 11, 10, 5, 9, 4, 3, 2. 1, 7, 11, 10, 5, 9, 4, 3, 2. The rectangle for the first question is shown in blue. So what is it? So we want to find K from 1, 1 to 1, 2. So this would be 1, 1, and then to 1, 2. So from this square to this square, this is the top left. So top left. This should be the bottom right, and Loom is gonna take away the drawings. And you can see that when you have top left here and bottom right here, then the rectangle we're considering is this one. So what we're gonna do is that we look at all these values and then we check, is there 10 in them? Well, there's only 1, 7, so there's no 10 in them. which means we output no, there is no 10. Here, the next query or question that Freyren is asking us, is there 3 from the grid rectangle, the sub2 array, from 2, 2, 2, 3, 3? Well, can we find, this is the top left, this is the bottom right. Can we find a 3 anywhere in this grid? And the answer is yeah, we can find one right here. So we're like, okay, yes, we can find one here. So we put S. Yes, we output. Finally, can we find 100 from 2, 2, 2, 3, 3? Again, well, I mean, there's no 100 here clearly, so we're like, nah, bro. So the brute force way of doing this is just checking every single space in the array. We're gonna loop I. No. We're gonna R equals R1. And actually, I'm going to change this for a second because I want the first index for the 2D array is going to be 1. So it's not 0 indexed. Instead, it's 1 indexed, 1 based, which means the first index of the array is going to be 1, or at least the one that we're considering. So I'm going to loop from 1 to n. Oops, I put n for both of these. This one's m, the number of columns. Then we're going to check, okay, we're going to loop through from row 1 to row 2, so the top row to the bottom row. R is less than or equal to. How do you jump to a certain line number? I forgot. Oh well. Then we're going to loop through the columns. So this is just the standard way of looping through a 2D array. So this is just looping from column 1 to column 2. And then we're going to see, okay, is this place, so is the value at row R and column C, so the current one that we're considering within this subgrid, is it going to be equal to k, the value that we want? If so, immediately we can say, yeah, we do have the value k in this subgrid because this current value that we're considering in this part of the grid, the subgrid, is actually k. So we're like, yeah, we found it. And then we just kind of return 0. But if we never find it, after all of these computations, after checking every single box in this grid, then we're like, no, we did not find k. Sorry, mission failed. So there we go. Oh, also, we should not return 0. That would stop the entire program because it returns 0 for the main program. We just wanted to break out of this for loop. But actually, it would only break from this for loop. So to counteract that, let's just have Boolean value, which basically means, okay, did we get yes or no? And let's just say found. Did we find? Found equals true. So if the current box is equal to k, then we found it. Otherwise, found is already false. So if we found it, then we set the variable found to true. Otherwise, it's still going to be false. Now we can output, because we don't want to break out of only this for loop and then still run this for loop, even though we've already found the value we were looking for. Or at least if you found the number already, you don't need to check the rest of the boxes in the grid. If found, I didn't say equals true because just leaving it like this basically means if found variable equals true. Or it's truthy, falsy. I forgot what it's called, but truthy values, like it's true. You know, is this true? In computer science. So if it's found, then we're like, output yes. Else, output no. This is just shorthand for if and else. You can do this. I know, it looks so cool, right? Yeah, that's gonna be it. Let's run this. Copy. No, yes, no. Awesome. Thank you so much, computer. Thank you C++. Thank you VS Code. And then we're gonna do this one. Yes, no. Okay, so it works. Sample input works, and of course it will work because it just tries legit everything. Now the problem is, will it take too long? Let's just find out. Okay, it probably will. Okay, well, I'm gonna have to, yeah, so TLE. We got TLE for batch 2, which makes sense. TLE stands for time limit exceeded. So we ran out of time, basically. Our program took way too long to finish output. Subtask 2. Well, what's different about subtask 2 that makes it way longer? Well, first of all, the number of rows and columns can go up to 1,000, and also the number of queries goes up to 2e5. 2 times 10 to the 5. So if we look at our time complexity, which basically means how long our program is going to take on average, or sorry, like based off the variables given. Well, since we have the biggest for loop is this one, biggest time waster is this thing, and that's going to be Q and M. That's our time complexity. So O of this, and I have to keep writing stuff so that, you know, my loom thing doesn't like stop. So O of this is our time complexity, worst case scenario. Oh shoot, it's gone already. Oh well. You already get it though. So what do we do now? How do we reduce this time complexity? What could we do? Well, for problems like these, it's usually something like prefix sum. But I don't think prefix sum will help us at all here. Maybe create a mapping. So for each value, we do like some sort of hash map or array. For each value, because all values are unique, which means that if you have some grid of numbers, all the values are unique, so you have X, Y, Z, A, B, C, whatever. If you plug in B, you're gonna get only one answer for the number, the row, and the column that it's in. So in this case, 1, 1. So that means that you can map every single value to its corresponding row and column. So then you could check, like if you're looking for some sort of value, then you could check with its hash map, okay, whatever, with its mapping, where it is located, because legit all of the values are unique, which means that you can take any value you're looking for and determine where it is in the grid. And then you can compare that and see, okay, well, is that, position in the grid, is it within this little subarray that's marked by 1, 1 and 1, 2, or by 2, 2 and 3, 3? Is the RC that we get back when we plug in our K value, or the number that we're looking for, that maps so we get where it is in the grid, is the R and C values between, R1 and R2, and is the C value that we get back when plugging in the number that we need, is it between C1 and C2? And if so, then yeah, it's part of this range of numbers, part of this subgrid. So that's an idea that I had, and I think it'll work. So let me just try this out. And with that being said, I'm gonna delete all this because gotta start over. Now here I'm going to, instead of putting it into the array, I don't even need an array now. I can just let's have a hash map. So I'll create a map int to a pair, right? Why do we do pair? Because like we need the R and C values. So R comma C, that's going to be the pair. So we map every value to its corresponding row and column number, and the row and column value to row column number. Just have that as a reference. So it's in the pair, and then for each grid in the each box in the 2D grid, we're gonna have a value. And then what is that value? Well, when we get an input, we have the value for row I and column J. So basically, we can say, oh my bad, I didn't even name this. I didn't even create anything. I'm just gonna name my map M because it's so simple. M stands for map. M at value is gonna be mapped to make pair. MP is make pair. Wait, I don't even think I have make pair. Oopsie daisy, make pair. Okay, I'm just gonna have to use. Yeah, I don't think I have shortcut. Okay, whatever. Make pair, which is a function that makes a pair, but like obviously. And then we're gonna put its row and its column number that we just know because I mean that's by the input of the grid. At this position, at row I and column J, that's where we're gonna find this value that we're inputting that we got from the inputs. So we're gonna map this value to its row and column number. Okay, this is kind of confusing. So I think this works better. Yeah, I think this legit just makes a pair without using a function. It's just a set with these curly braces. So yeah. Now we have each value mapped. And then, okay, let's just input all the query stuff like before. So we input the number and then top left coordinate and the bottom right coordinate of the grid that we're considering for this query. We're trying to find if there's k in it. So we're going to go to the mapping for k. Is this mapping dot first? So this is going to be the row number of our value k that we're looking for to see if it's within this subarray. Then we can get the row from then we can get the column number from this value that we're looking for just by using our map that we created and filled. And dot first basically means the first value of the pair, so that's going to be the row number, obviously. And then this one's going to be the column number, and the reason why I say obviously is because I named this R and then C. So now we just check, okay, is R1 less than or equal to R? And R is less than or equal to R2. Now I know what you may be thinking. Actually, probably not thinking this, but some of you might be. Like, why don't we just do this? And that's a really good suggestion, and I wish we could do that, except the computer doesn't really understand two operations side by side in a row. So you need, a singular logic gate. Is R1 less than or equal to R? And is R less than or equal to R2? Like, it doesn't want multiple steps in one step, It's just kind of like this. So you have to write it out separately, and then, if so, then you're like, okay, could you also check, sir, computer, that C1 is less than or equal to C, and C is less than or equal to C2. The reason why I got rid of these spaces, I just think it visually looks nicer. But you want to keep, these compound operators, which basically means the and or the ors. You want to keep them, there's a space in between there to separate, to distinguish the both. If this is true, then you're like, yep, okay, this is within the boundaries. So you're like, yeah, otherwise, say no. So that's an updated version of the problem. And actually, this is going to reduce our complexity by a lot. For some reason, outputs no, yes, no, no. I'm not actually sure why. Yeah, I'm legit not sure why. Is there anything I'm missing? Okay. So what I'm gonna do now, because I'm not sure why this happens, is I'm gonna input it step by step, line by line, just so I can get a feel for what's going on. Actually, this is not really helping me that much. So for now, I'm gonna debug some stuff then. Okay, so let me just print out what is K first of all, and then we're gonna output K, and then this is just some formatting, cool stuff, you know, quotations, then numbers, then quotations, numbers. So I put comma here to distinguish. Let's put the R value here. Oh shoot, I can't see the code because it's behind my camera, but also you guys can't see it either, so I'm gonna have to move my thing, even though I know what I'm typing. Yeah, of course, why would I not move the thing? So there we go. Let me just do this so I can debug some stuff, and maybe I should put my camera here. Let's not cover the time, so you know how much time this is taking, even though you can just look at the video timestamp. So we have K10, R1, R2, C1. So row 2, column 1, that's definitely correct. Then for K3, you're gonna have row 3 and column 2, which is absolutely correct. But then here, for some reason, doesn't print out K afterwards. Oh, I see. The problem is that I print out no either way. So even if this thing is doesn't print out yes, this prints out no either way. That's why that happens. Oopsie daisy. That's my bad. Again, I'm going to use the variable found. So if it's found, like if it's part of that range, then we're gonna say yeah, we found it, right? Otherwise, if found is true, then we output yeah, we found it within the sub 2D array. Otherwise, we're gonna say nope, we did not find it. And this lowers our time complexity by a whole bunch. So there you go. And now we just get rid of our debugging by pressing DD for the whole line. Deletes the whole line instead of just delete one thing. Then we're gonna copy this simple and then try it out. So yes, no, and that's exactly what is expected. Now I'm gonna copy everything. Oh shoot. What? Oh, don't mind that. If you could see that. Wait, I don't even know if I'm recording my whole screen. That's kind of... Oops, that might be pretty bad if you can't see my VS Code. But I'm assuming that you can, because otherwise, that would be bad. But it's okay. Okay, first one's looking good. Maximum is 3 seconds. It's like 1 right now. Should be fine. And there you go. So we get all correct. So this would be a CCC Junior 4 problem. And yeah, that's basically it. Okay, last one. This looks like graph theory problem already, but okay, relax. I'm gonna chill. So, let's review my graph theory skills to see if I still got it. If it is, I'm not actually sure, but coffee jelly. Psyche has brought some of it. Oh my god, this is Psyche K, bro. Oh my god, it's all anime. What is one? One is just chess. Wait, Shiro? This is totally anime. Oh well. By the way, these are totally the thoughts you should be having when you're taking the CCC or any other contests. Wow, these questions are so weird. You know, I'm kidding. Yeah, just don't waste your time. Saike's brought some of his favorite coffee jelly and wishes to enjoy his treats in peace and quiet. The school's map is a rectangle of at length n width m, so immediately again I think of 2D arrays. I don't know how many times I should draw this, but yeah, just to emphasize. So length n, width m, basically n rows, m columns, just like the same concept over and over again. Using his psychic powers, Saike has created a 2D map of the single floored school, where X marks the walls and doors, asterisk represents people, and dot represents open space. That's a classic way to represent like layouts of the floor, by the way. Like X is walls, dot is like open space, classic. A classroom is a group of open space cells vertically or horizontally connected. A classroom is considered empty if none of the open cells are vertically or horizontally connected to a person. A classroom is a group of open cells for. Okay, so basically, this would be like a classroom. This whole area, just like a connected open cells or dot cells. A classroom is considered empty if none of the open cells are vertically or horizontally connected to a person. Alright, so if there's no asterisk in that kind of general area, then that means it's empty classroom. This classroom would not be empty. This is not empty, but this one actually is empty. Saike wants to enjoy his treats alone, so he asks you how many empty classrooms are there where he can enjoy his treats. This looks like a really easy question if you know the algorithm. How many empty classrooms are there where you can enjoy his treats? So for this one, you would actually use a algorithm called depth first search, and it's called a flood fill problem. And let me just read the remaining parts of the question. Sorry guys, I'm just so tired. It's like 10:30 right now. I bet you could tell if you're looking at my whole screen. Hopefully you are, so you can see my code. First line contains two non-native integers, n and m. So n, m. N is the number of rows, m is the number of columns, like always. Following n lines will contain m characters representing the school, so we're just going to give the whole grid. Output number of empty classrooms in the school. Okay, that's pretty. This is a kind of standard flood fill problem. So, for example, you're given n by m grid of integers again, and then something about flood fill or whatever. Okay. Blah blah blah. How many empty classrooms are there in the school? So this one, why is there two? Oh, that's why, because of this asterisk. These two are, okay, let me start over. These two are the two empty classrooms here. Everything else is connected to asterisks. So this one has empty classroom here, here, and here. That's why the answer is going to be 3. It's just 3 empty classrooms. So how do we solve this? Well, the algorithm is called depth first search. Basically what you do is you go through each and every box of the original grid, and if that box is an empty cell, so if it's a period slash dot, then you want to check these cells to its immediate top, left, bottom, and right, and then you're going to recursively call for, like, if there's a period to its right, for example, then for that period, you're gonna check its top, right, left, bottom. Uh, you know? You're gonna check its top, whatever. So then that just continues on until you basically check all the ones that are connected in a classroom, or like this open space that's all connected to each other. And then you're going to mark each as visited so that you don't check them again, right? Because you don't want to do that algorithm for each and every single box. Because if you did, then you would mark the same classroom. Like, if it was just these three, you would mark the same exact classroom 3 separate times, even though it's only one classroom. So you really want to mark this as visited when you go and call this one, when you find it on the right, as not a wall, and then you recursively call it for this one. So then you take this one's visited, and then you also move to this one, and then actually you can't go backwards because this one's actually already visited. And so to label when we've already visited a open square, which is a dot, we're just gonna put an X there like it's a wall or door, just so that we just don't look at it ever again. Never again. And then at the end, if somehow we go, to the right and there's an asterisk, then we're kind of like, okay, we found an asterisk. That means that this whole group is not an open space. So we don't add that to our total count of open cells, which are empty classrooms. Alright, sounds good. It sounds a bit confusing. Yeah, I know. But hopefully it'll make more sense when I do it. And also I have to kind of think about how to do this problem because um yeah, this is also a review for me, so I'm not uh like a master. I'm not, pro at this. I still need to review some stuff. All right. Fairly confident I can do this though. So first we want to input. Oh my gosh, my mouth is going to be really dry. So first of all, we're going to input n and m, which are the rows and the columns of our 2D grid, like before, like the previous question, which also had a 2D grid. We're going to input. So like always, I would like to just start with doing the input right away, as my brain just kind of gets started just by doing the simple input. And then we're going to have grid. For some reason, I like to use either letter A or just grid when doing a 2D grid. So yeah. And then it's going to have maximum size, and that maximum size on each of the rows and columns, well, it's going to be 1000 as stated by the constraints. So I'll just do 1003. I always like to add 3 to the constraints maximum. And then we're going to loop through the rows and loop through the subsequent columns. And then input each value for each position, which is going to be either x dot or asterisk, denoting either wall, open space, or person. Now we're gonna, oops, I made a typo here, it should be semicolon. So now we're gonna actually go through every single position in the grid. So we're gonna do the exact same algorithm. And why does this look so different? Oh, I didn't even put int here. Oh my gosh, oopsie daisy. I didn't even create the variable j. So now we go through every position in the 2D grid or layout of the school, and then we're going to check, okay, is this current thing value, is it going to be an empty character dot? And by the way, the single quotes means an empty one character. Oopsie daisy. I don't know why I said grid was an int. No, 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 no. It's going to be a grid of characters. So x dot asterisk, they're all characters, and single quotes represents characters, and checking with the dot. If it's like a wall, we legit don't care. Like, move on, bro. There's no classroom to even consider. But if there's a dot, then we know there's at least a classroom to consider. So here is where my brain kind of malfunctions and my throat dries up really fast, but it's okay. So now that we know this position is a period, we're going to check the top, right, bottom, left. Let's create a function. And this function is, we're going to put it below the grid because we have to initialize the grid. So the function is placed after so that the function recognizes the grid and can use it. So we're going to do I don't know, void, so the function doesn't return anything. DFS. We're going to have the row and the column that we're considering, and then we're going to consider new R, new column. Oh, wait, what does that mean, bro? What am I talking about? What row and column? So you input the row and the column of the current box in the 2D array that we're considering, and then we're also going to input the new row and new column. So which slot is it that we're considering next? And I'm going to manually type in, r minus 1 c. So, but by the way, for in case you didn't know, for the one on top, it's going to be r minus 1 c because the row number, this is 0, 1, 2, for example, so it gets like smaller as you go up. And then R and C minus 1, so same logic, like the column numbers get smaller, so it's like 0, 1, 2, 3, 4, so when you go to the left, it gets smaller by 1. And this one is going to be R plus 1, C, and then this one is R, I have to keep clicking so that doesn't get lost. Then R, C plus 1. So basically, these are the positions. When given RC, the top is going to be R minus 1C, the left is going to be R, C minus 1, so etc, etc. And so I'm going to check these one by one because we want to check, okay, is the one at the top, left, bottom, right, are they also empty? If so, do the exact same thing. You check the top, left, bottom, right for that cell next. So if you have a bunch of cells like this, then you're going to check like this. You're going to check here, and then here there's nothing else. Okay, so there's nothing for us that way. And then you check here, and then you check here, and then this one actually goes up, and then this one actually goes right, and then this one, oh, there's nothing else. So that's flood fill basically. You recursively call open spaces connected to open spaces until nothing is called anymore. Does that make sense? Hopefully. So classroom is a group of open space cells vertically or horizontally connected, and that's why I mentioned top, bottom, left, right, because these are actually horizontally or vertically connected. But if you had like an arrangement like this, like these two would not be connected, and so you only have top, left, bottom, right to consider the open cells connected. So new R, new C just means the new cell that we're considering. So this function, right? Well, first of all, as always, you want to even consider, you want to know, is the new row and the new column, is this even a value that's inside the grid? Because sometimes when your grid is like really small, or like you're on the edge of your grid and then you're at, this value, for example. If you check the one to the right, there's literally nothing there. So then you're gonna get some error, right? You don't want that. Actually, it wouldn't be true for mine because my grid is like really big, so it would account for everything. But if you have a value, if you're considering like 0, 0, obviously if you check the top value, you're gonna get an error, right? How can you get -1 row -1? So then you want to check that this new row and new column, this new value in that place actually even is in the grid itself. So you want to check that 0 is between new row between less than or equal to. So new row basically should be between 0 and n, which is the number of rows. But we can't really do this in C++. So you have to split these conditions apart. So we have to make sure it's greater than or equal to 0, and that's less than or equal to n. And then we also want to make sure that 0 is less than C is less than to m, so and the new column is within the possible number of columns, and again, it has to be split apart, the conditions. Okay, so if this whole thing is true, that means that this new grid value that we're considering is actually inside the grid, and we're not going to have any errors with that, so that's good. Now, next, if the grid at this new row and new column position is equal to asterisk, then what we want to do what we want to do is, well, we found a person. So what we're going to do is subtract 1 from the answer. Okay, what do I mean by this? Well, actually, let's add 1 to the answer here. I'm going to create the actual answer value variable. So every single time we see a dot on the grids, that means that we're opening up a new classroom that has never been visited before. And then we just assume that we've found a classroom that's empty, so we add 1 to the answer. However, while you're calling these functions, so I'm going to do DFS blah 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 later, right? While you're calling these functions, if you actually find a person in that classroom, well, it's not empty, and so you just added 1 to the value of answer, but it's actually not supposed to be added because it's not an empty classroom. So then you're just going to minus that answer. But okay, how do you prevent, because there's going to be an asterisk, but then there's also going to be ones connected to it. So you're going to minus answer here. You're also going to minus answer here. You're going to also minus answer here. You're going to also minus answer here when you go from like different cells to the same person. So how do we prevent that from happening? How do we prevent the same person from causing us to minus answer multiple times? Well, we're just going to replace that person with the wall. Like it's just that simple. We're just going to say, okay, now it's X. Okay, bye-bye. Gone, right? But we still want to continue traversing this. We still want to continue flooding this classroom and checking every single cell that's part of this classroom. So now we're going to recursively call DFS. Okay, I just realized that there can be multiple people in the same classroom. Which means it's gonna minus answer a bunch of times. Which means that we need a variable to check whether or not this classroom is empty. So maybe we should actually do this as a bool. So let's look at the base case. If we find a star, well, then actually we're gonna return false, as in this is not empty. But then we still want to search. You still want to search everything, because you still want to get every single place that's part of this classroom and get rid of it so we don't have to search it again. So by doing this, to do this, we're going to call DFS at nr and c. We're going to do nr last one and see if this is going to be the top. I'm going to check this. And let me just do this for all of them. Actually, only have 21 minutes left. Oops, that's pretty low on time, but it's okay. And C, nr and C plus 1. So just reference, this is top, this is left, this is, I'm going to traverse the bottom cell and the rights. By the way, if this new grid, if this new value at this grid, if it's a wall, guess what? Nothing happens. Nothing happens. So we don't even need to check that. Now otherwise, the only other possible thing is if it's open, then we subsequently also run the exact same functions, and then we just say bam. So then how do we actually return false? Actually, we need to check, turn this into a wall so that we don't check it again before we run the subsequent functions. You know? So let's do that for this one as well, except we don't return false in this case. Bool A equals this, and bool B equals this, bool C equals this, and bool D equals this. So if any of them return false, then that means this thing is not empty. And so if A or B or basically if any of them, of these conditions are false. Well, that means that we found an asterisk, a person, which means that this classroom is actually not an empty classroom. Hence why false. It's not an empty classroom. Else, it is empty. Right? What happens if we don't find anything? If we find an X? Well, if we find an X, then return true. Just by baseline. Just baseline. Just return true. False means that, nah, actually we found evidence that, this classroom, it's actually not empty, so, yeah. Okay, so after all that hard work, we're gonna run DFS in all four cardinal directions, which basically means all four directions, but just a fancy way of saying that. Hold on, cardinal directions. That is up, down, left, right? Yeah, it is. Okay. We're gonna do BFS, and then similarly, in this similar fashion, this is recursion as peak. It's legit the same thing in the function as it is before when you're calling it for the first time. If you find any evidence that it's not empty, so this basically means if not empty, nothing. Like legit nothing. So if this whole condition is that it's not empty, well, this, if you just add an exclamation mark at the top, it means it is empty now. If it is empty, then we add 1 to our answer. Woohoo! Hooray! That's great. I think this should work. At the end, we just output the answer. Isn't that really fun and great? This question is amazing. DFS. NR was not declared in the scope. Oh, right, because there's no NR here. In this case, we're actually just using I and J, so, oops, J, so you do I minus 1th row, where current row is I, and add J. Then you do J, then I, then J minus 1th column. Original is J. Actually, why do I need to know what the original one is? I actually don't know. I don't think that matters. I think it matters in other applications of DFS. Not that I can remember, but I've definitely used that, but I don't really see why I need to care about what the current position is. But oh well, I'm just gonna do it anyway, just because, that's what is best practice, because you would do that normally. Hopefully this is good. Okay, 2, so that works. This one is also 2. I'm gonna try sample alpha 2, and I get 3 when this is also 3. This is really good. This is a really good sign. And just for fun, let me just output everything in the grid, and I'll show you what it looks like. So we're gonna output grid ij. Wow, look at me typing so fast that you don't even understand what's happening. Okay, so you output each number, and then you output a line divider at each step, just so that the grid looks proper. And at the end, you can see that legit everything's filled with X, except for this part, which is an asterisk, but it's not part of any classroom, so it was never reached when doing the flood fills. Okay, well, this program seems to work pretty fine, so I'm just gonna copy it and I'm just gonna paste it in. AC good side. Let's go! Let's go! Okay, awesome. So, that's gonna be the end of this contest. I'm really glad I got all the questions with 13:33 to go. Awesome. So yeah, I just finished the contest. Yeah, that's basically it. And wow, that was only 7 points, which makes sense. But yeah, it really should not have taken me that long, but it's okay. I had to explain a lot. I'm kind of rusty as well. But oh well. So yeah, that's basically this contest. This is just like a mock CCC Junior type question. So yeah, I hope you understood all that. Bye bye.